Hello guys, welcome to Inside Electronics. So in today's episode, let's build a series test bulb circuit, which is going to be very simple. All you're going to need is just a light bulb and a holder with a couple of bits of wire. That's it. And in my case, I'm having this really cheap plasticky extension box that I'm having. That I'm going to repurpose this so that the series bulb is going to be attached like that. So the bulb will come in series with whatever device I was going to plug in here. I will explain how everything works later, but first of all, let me just tell you what is a series test circuit is. Let me just turn these lights off real quick, and there goes the camera again. So let me just keep this like this. So let's say you have a really bad electronic device with you, and let it be this. Let's assume that this hair dryer, I just got this thing from the trash. It was all wet and it was covered in all gunk. I'm saying an example right here. This one is not that bad, and you don't actually know how the inside looks like, and you don't really know how bad this is, but still you want to test it in a safe manner, and you don't want to actually just plug this in directly to the wall, because you know there is something wrong with this and it's gonna blow up, or it's going to trip the breaker or blow the fuse, and bad things will happen. So you want a safe way to test that. Let's see what happens when you actually do that. Let's say this right here, this is the 230 volt input. So 230 volt input going on, that is connected to your AC mains, and you are plugging in, let's say, this hair dryer is going to be resistive and an inductive load, but let's just consider it as a load, and let's name this device under test. Because if you are unsure about the condition of this device under test, if you plug this in directly to the wall outlet, what happens is that let's assume the device is having a short circuit internally, which means it is going to be a direct short. In such cases, if you plug this in directly to the wall outlet, you know almost certainly that it is going to create a huge explosion, and it's also going to trip your breaker if you have one, or just blow the fuse. It's going to create all sort of nasty surprises. So you need a safe way to test that, and there comes the use of this light bulb. Because all you're going to need is put a light bulb in series. Let's draw a light bulb real quick. This is going to be a bulb in series with the device under test. So what happens is that this bulb is going to act like an resistance directly connected in series with your device under test. So let's assume that if there is indeed a short circuit inside it, what happens is that because this light bulb is connected, because it has a short circuit in it, the current is going to just go through here and go through here. I mean, going through the bulb, of course, go through here, which is going to light up the bulb, and that's it. That's the only thing that's going to happen. It's not going to trip your breaker or blow your fuse, because the current that is passing through this device under test is going to be limited by this bulb itself. Hence the bulb is going to act like an resistance, and it protects that whatever device you plugs in by limiting the amount of current that can actually flow through it in a faulty situation. Now I have to undo everything just to keep it working. Now let's consider another example. Let's say that your device under test is fully working. In such a case, what's going to happen is that the current is going to flow through this bulb and through the device under test. But this time, because the entire voltage drop, because this is a fully working unit, the entire voltage drop is going to be across, the entire input voltage drop is going to be across this particular device itself. And because there is not enough voltage available across the bulb, it won't light up because the entire 230 volt is going to be dropped across this device itself. There is not going to be enough voltage drop across the bulb, and hence it's just going to act like it isn't there at all. It is just going to act like a piece of wire, just like that. I mean, just like that. It just passes the amount of current. Of course, it's not going to handle a lot of, if the device under test is going to draw a lot of current, it's not going to light up the it's not going to go through this, because it has a resistance in it. It limits the amount of current that's going to flow through this. So keep in mind that if your device is, this entire test unit works, but it just gives you an indication whether the device is faulty or not. You are not going to use it continuously on this bulb. If you have detected that the device under test is okay, that it is not going to trigger your breaker or blow your fuse, you can directly test it with the AC mains itself, because this bulb is going to limit the current that's going to flow through it. So enough of talking, I guess that is covered. So what I have done here is that I have this particular thing lying around in my trash bin, and you have already seen this thing appearing in some of my experiments. So what I'm going to do, conveniently enough, this has this 2-pin and this multi-pin connector right here. So as I said, at present this is just a regular extension box. You plug this in to your mains input, you turn the switch on, you're going to get 230 volts across here and all these 2 points right here. Of course, the earth pin is not used. So I'm going to modify this box so that the AC mains that's going to come in is not going to the switch, but it is going through this and then comes to the switch, and only after that it's going to come through these 2 points right here. So that makes this socket right here in series with this thing right here. I will just draw that for you. That is how I'm going to actually make this thing. I have already drawn that thing right here. This is the current wiring of this extension box. It's just regular common stuff. AC mains comes in. This is the switch right here, has a neon indicator, that thing right there, and that is the 2-pin socket, this thing right here, the 3-pin socket, that thing right there. This is the current drawing, and to introduce this bulb to this thing, what I'm going to do is this is the 2-pin socket, this thing right here, that I'm going to modify. And the way I'm going to modify it, I'm going to apply the AC mains coming in directly through here. Let me just disable the bulb here for a moment, like that. Okay, that's fine. So this socket will be directly in series with this socket, and I'm also going to modify the switch. If you notice, in this one the AC comes in through the switch to the socket, but in this case this switch is connected directly across the 2-pin socket. So this switch is going to be connected across that thing. And the reason why it is needed, if you want to make this thing just an extension box without the need for testing anything, you can simply turn on this switch so it bypasses the circuit internally, and current can actually flow through here, and to the 3-pin socket itself, which makes this this thing, it just, you got the point. So you can just plug anything right here without any issues, and this neon bulb indicator will also light up. But if you need to test something, you can plug in a bulb here like that. If you plug in a bulb right there and turn off the switch, then the current is going to flow through the bulb to the socket. Then this thing will become a series bulb tester. So I hope you guys understood the point. Now let me just rewire this thing. So I'm conveniently having this little socket right here, so I can plug this in right here, and the bulb will be connected like that. So I'm just going to open it and I'll be back. So guys, this is a circuit internally. So now I'm going to rewire this thing. Now as you can see the diagram, the current drawing looks like the second diagram. The input goes to the switch to the circuit. Now I'm going to pause again and I'll be back once I rewired everything according to the later circuit diagram. So okay guys, now as you can see here, I have rewired everything. Now the AC input goes first straight to this point, then across this point the output comes to here. The neutral is connected straight here and the neon bulb is connected. So we can put this to the test now. Since assembly is complete, I'm just going to close everything and let's test it. So I'll be back. Okay guys, so now I have, as you can see, I have rewired everything. I have labeled it so that if someone else pick this up and plug something else, that I don't want that to happen. So I labeled the series bulb only to this. This is a bulb bypass. As you can see, if the bulb is bypassed, then the AC just goes directly to here. That's the load. So if the bulb isn't there, let's just put a load here. It's going to be the hair dryer right here. So if I turn this on and if I, as you can probably hear, it's already working. So without a test bulb attached, this is your regular extension socket. See, you can turn on and off your devices really easily. But say you want to test something, and let's just use a bulb right here real quick. This is, by the way, 25 watts bulb, and now I'm plugging in the thing, and as you can immediately see, the bulb is now on. What that means is that it's not because this is faulty, it's because the resistance of this hair dryer is really low. The circuit takes it as a short circuit. So that is exactly what's happened. If this was a bad unit, let's say without the bulb, if this was a short circuit inside, if I plug this in and immediately it blows up, and it can also trigger the circuit breakers, and it may also blow the fuse as well. But because the bulb is present, and this, even though this is faulty, it's not going to create any issue, because when you turn this, when you plug this in, because this has a short circuit inside, all it's happening is that this is passing the current to the bulb, and the bulb just turns on, indicating that this is having some issues. So that is how you can build yourself a really simple series test lamp. By the way, if you notice, this has two stages. This is the low bright and this is the full bright, and that is because this has a voltage low and high setting. So that is why the bulb brightness is changing. So yeah, that's how you detect whether your load is having some issues or not. Just like that, you can test bad unit. Let me just plug that in, and you can see nothing happens. The bulb isn't even turning on. That means this circuit is open. Either the circuit is open or this is a fully working unit. That is one issue with that. If the device under test, when you plug this in, if the light is not turning on, that could either mean two things. Either the device is fully functional and the voltage drop across the bulb isn't enough to make it glow. That means this is a good unit. Or it has an open circuit inside, because there is no current flowing. That is the two conclusions that you can make by a circuit like this. So yeah, every electrician or electronics person should have one of these in their workbench. It's really good, really useful unit to have. Anyways, thanks for watching. See you in another videos.